Welcome back, everyone. So we are going to talk about open storage network. John Goodhue is a co-PI for the Open Storage Network project. Also, he's executive director of MGHPCC. John, go ahead.
Uh, I will just dive right in and talk a bit about the Open Storage Network. I'll just to make sure I mentioned it early and often. This is an NSF-sponsored program. We've been going now for a couple of years with a service that transitioned to kind of early production quality early in 2020. I will calendar 2020. During the presentation, just for those who saw Scott Yokel's presentation about the Northeast Storage Exchange, I'll try to compare and contrast the two. We're actually working fairly closely together. So just framing, I think probably everyone on the session knows that we are being inundated with data. I think scientific instruments are now following, many of them, kind of a Moore's law increase in the amount of data that they can generate. As for example, photoarrays on telescopes get more capable and higher resolution. Also, as we get more and more sources of synthetic data from simulations that people are using for scientific analysis. And with the rise of AI and training data sets and so forth, it's more or less endless. I think the paradigm is shifting also. We're seeing this. It used to be that you capture and store and analyze. Today, it's very much about capturing, storing, and sharing data as projects become more distributed and collaborative. And the methods by which people are sharing data or want to share data are becoming more diverse. If we look at our kind of the US research cyber infrastructure across the US today, I think for a long time, arguably since the 1940s, we've been investing heavily in computation. And today there's a very rich collection of resources, large supercomputer centers that federally funded by DOE and NSF, all the way down to small campus clusters scattered around the country, with methodologies that are fairly, they're evolving quickly, but have been around for a long time. Networking, which has been with us now since actually the late 60s, but has kind of blossomed over the with the public internet as well as research and education networks, has also been the recipient of a lot of thought and a lot of investment. Storage is still mostly, I'll just call it balkanized, and I think that's in part because for a long time, really until quite recently, storage was thought of as kind of a box on the side of a computer as opposed to an entity unto itself. And as data becomes more and more of an asset, first-class citizen, however you want to characterize it, we really need to think about storage separately from computation and networking. They all relate, but data is now something that we really want to be able to get to directly, as opposed to mediated by some computing resource. So the Open Storage Network is looking to kind of fill that gap. And if you were just to say three things about the Open Storage Network and no more, we really want to work on making it easier to access and share active scientific data with distributed infrastructure and governance at a scale that really can't be managed by a single entity or a single institution. And I'll drill on all three of those ideas in the next few slides. We kind of in parallel with the evolution of data as an important entity unto itself, the scientific community has been thinking about, how do we manage, govern, and share data? And many of you may be familiar with this, but there's this notion of a set of guiding principles that I've got the reference to the 2016 paper that outlined these a while back. But there are maybe 4 key concepts that are important to think about. One is you want your data to be findable, preferably with a globally unique and persistent identifier with some metadata that describes it. So you don't have to rummage through the data set to figure out what it's about and whether it might be useful to you. Accessible using standard protocols and straightforward conventions for access control and authorization when you need that. Interoperable really thinks about what are the vocabularies and the formats that make it possible to merge data sets together and gain new insights. That's new and complicated, but I think necessary to the world that's going forward. And reusable, where obviously you can take data and use it, but you'd prefer that one would prefer that it be controlled with well-described provenance. If there's license terms or constraints on the data, it ought to be easy to figure out how to do that, or what they are and how to engage. And community standards around, different scientific communities have different standards around kind of how data is generated, how it's used, and how it's shared. The OSN is not attempting to solve all of those problems, but it is attempting to fit very well and very functionally as the A, or one of the A's in FAIR. So how do we make data widely accessible, easy to get to, and how do we make it so that it links well with tools for finding and interoperability? Just to give you a sense for the kinds of data that we're hosting today, and kind of the sizes that we're dealing with and the purposes that it is for, this is just a list of a few of the projects that are using the OSN to make active data available. I'm not going to do each one of these in detail, but I'll note that they span any number of scientific and application domains. TerraFusion is data, actually 20 years worth of satellite data that's being served up in slices. BCO DMO is marine ecosystem data. The Happy Research Center is training sets for AI models. Pangeo is geophysical. There's a project that spans MIT and NASA and Johns Hopkins and others that has dropped a bolus of oceanographic data on the OSN. There's water modeling data. Actually, this is kind of fun. The notion here is after a hurricane, let's give you a time series of what happened to rivers and streams and lakes and groundwater with an eye on the water quality issues that a hurricane leaves behind. And then in the computer science domain, there's actually a commercial entity, 2 Sigma, that has a very large server farm, and responding to interest from computer science researchers, has dropped a terabyte or so of cache trace data, anonymized cache trace data from that server farm. So it's really kind of all over the scientific map what we're seeing. And you're also seeing that the data sets are measured in terabytes to tens of terabytes, and in the case of Pangeo, and also actually the oceanography project, they're interested in moving or giving access to data that's at kind of the petabyte scale. This is another thing I think that we're seeing in the data set community, which is, gigabyte is no longer a thing. These data sets that people are looking at tend to be very large and important to be able to move at high speed. Just talking a little bit about the OSN itself. the network today, or the project today encompasses 6 sites across the country, ranging from the MJPCC in the Northeast to the San Diego Supercomputing Center in Southern California. We're actually in the middle of adding 2 more sites, one in Alabama and one in Maine, and I'll talk about how sites get added in a minute. As I mentioned earlier, we are a collaborative project. We actually felt that it was very important not to have a resource of this kind be dependent on a single entity, which becomes a single point of failure, which is not quite as geographically distributed, and is in many ways just a little bit more fragile than a distributed entity. Of course, collaboration is not easy, so it's important to have kind of a structure that can withstand comings and goings and can accommodate a variety of points of view. So our foundation includes an advisory board, which gives us input from the user community, a leadership team, which consists of representatives from the deployment sites, an implementation team, which is distributed across the country at the current deployment sites. And this is, I think, commonplace now for the open source community, and we've extended a little bit to DevOps. We could get together once a week and do kind of the usual motions that you'd expect to see in a DevOps team. This is perhaps more usual than it was a year ago, because with the pandemic, of course, everybody meets by Zoom. When we started doing this, it was a little bit less usual. And then there's, of course, meetings, so weekly and monthly, depending on whether you're implementers or leadership, we get together. And underlying it all is written down policy and process, so that we have a reference for governance, as well as what are security policies and procedures, and what are kind of the rules of engagement for allocations, storage allocations. Shifting over to the technology, kind of one way to think about the OSN is there are kind of 4 key characteristics that we cared about from the beginning. And for each one, there was a set of enabling technologies that were either just coming into focus or have been around for a while that we were able to leverage. So the first is access from everywhere. And this comes back to that balkanization notion that I talked about earlier. You really want a simple way to get to any storage object or collection of objects from anywhere on the planet. And it used to be, for 50 years or so, the way you got to storage was you got an account on the computer system, you logged into the computer system, and then you were able to access files that are associated with your group or whatever that access control mechanism was on that system. Here, and I'll talk about this a little bit more on the next slide, the web services, which have grown up over the last decade or two, and the conventions that Amazon has really established for storage access via the RESTful interface to their S3 service, give you the ability to do more of a web services oriented look at your storage, independent of any computer system. For access control over the last, again, 10, 15 years, entities such as InCommon have made it possible for people to use their institutional identities to gain access to storage and compute resources, as opposed to having every service manage a separate set of identities. So I'll talk again about that in a minute. For security and data integrity, object stores, the available software for open source software for object stores has now really kind of come into its own. When we started Ceph was a good choice for us and was maturing and has now become a solid platform that we can build a reliable storage system on. And then for performance, we leverage the networking community. There's tremendous investment in research networks, ranging from Internet 2 down to regional networks across the country. And the notion of science DMZs, which allows us to gain fast access. And then for the storage itself, of course, for quite a while now, commodity servers have been able to deliver good performance, excellent performance at reasonable cost. We translate those technologies into, I'd call it, three simple ideas. First is we think about data sets as collections of objects controlled by the entity that generated them and curates them. As I said earlier, every object is accessible from everywhere. What that translates to is every object in the OSN has a name that's composed of the site name, fully qualified name of the site where it resides, the Ceph bucket name that it resides in at that site, and then the object name, which we encourage people to kind of prefix with their data set name, and then there's a string that represents the object itself. And just for example, I can click on this URL and it will fetch me a beautiful poster of the OSN at no charge for a limited time. But it's as simple as that. URL, this is the RESTful discipline. URL translates to a file or an object in a location. As I mentioned earlier, physical storage is distributed across multiple sites, which gives us a bit of locality and also a bit more robustness. And they're located in science DMZs, typically with either 40 or 100 gigabit access to Internet 2 for fast access. Another thing that we borrow from the FAIR world is the notion of every data set having a landing page. It's nice for some objects just to be able to grab them by issuing a request through your web browser. But if you're grabbing a terabyte worth of data, you'll want more sophisticated tools. So what the landing page does is it gives you an easy way to visit the data set from a browser or maybe a data catalog like Dataverse. It contains some metadata that describes the data set, so you know you're in the right place, and then links to downloadable tools for accessing the data. That might be something as simple as a pointer to a browser-based directory that lets you browse through the objects, or it might be a full-blown custom interface to the data that catalogs it and helps you find what you want. Just a couple of notes on access and curation as well. We felt it was very important for the platform to stay out of the way of the people who own and curate the data sets. So once you get an allocation on the OSN, you can register, again, using your existing identity, whether it's Incommon or Orchid or some commercial provider, on a portal, which gives you administrative access to the storage that you're managing, and allows you then to assign keys to other people for uploading and downloading data or accessing it. Data sets may be open, readable by anyone. Many of the data sets that I listed earlier are in that category, and really the access control is for the smallest set of people who are allowed to write and update. Or data sets can be fully protected, where they're readable by invitation. The kind of the transaction that happens looks a lot like when you invite someone to read or write a Google Doc. Um, it, it, the an invitation goes out. You register with your institutional ID, and then you have access. So the number of steps is fairly small, and again writable by curators. Just to give a quick example, this is the oceanographic data set that I talked about earlier. Just a few notes. This data set is a combination of data. First, observations and estimates of marine microbial dynamics over a period of 20-ish years. Also, the data sets, synthetic data sets from computer simulations that use the empirical data as well as models to generate synthetic data that statistically actually looks very close to the real thing. So it's useful for example, scenario generation and analysis.
John,
This,
do
again,
you have 8 minutes?
10 minutes.
8 minutes.
Ought to be just about right. Thank you. And this is data that's managed and curated by a project that's distributed across the country, including folks at JPL, NASA, Johns Hopkins University, Columbia University. So there's an interest in being able to have this data accessible from multiple geographic locations. And as I think you saw earlier, the size of the data set is quite large. That 160 or so terabytes is actually a fairly small subset of the kind of petabyte scale that they have available today and growing. So imagine that I'm generating data at the MGH-PCC on an MIT cluster, and I've got a friend maybe down in Maryland who wants a slice of it. The way that would work and has worked is data that gets generated, say, from a simulation on the MIT Engagement 1 cluster. Their kind of bulk storage is increasingly becoming the Northeast Storage Exchange. So that's where they leave kind of the big chunks of data. They can then, within the data center, move slices of that data onto the OSN node at the MGH-PCC, where it's now available for all to see, or perhaps if they want to protect it for an invited subset to see and then download. And as you can see, the tools for doing that can vary. Inside the data center, we use Globus for one leg, rclone for a different leg, and maybe a different protocol for the third leg of the transfer. There's a variant of this, particularly for larger data sets, where imagine that this is somebody out in California, so this rather large bolus of data needs to transit the entire country. Globus is very good at enabling that. But it might be that you don't want to engineer and carefully tune a path across that distance. With the OSN, you have the option to kind of do 2 hops. So how does that work? The first steps are the same, right? The data lands on the OSN node at the MGH-PCC, but then instead of moving it or having somebody pull it directly to their site, we're willing to transfer it to, say, the node at SDSC, so that the site in California has a much shorter path that it has to worry about traversing to obtain this data. And the data paths between OSN nodes are, we watch them every day, and we make sure that they're fast and well engineered. So this is getting close to the end. If there's interest, how do you join? Again, this is intended to be a collaborative enterprise, and with multiple ways to join. For smaller data sets, we have space available. Our idea here is that the more data there's available in the OSN, the better. And on the other side, there are a lot of people who would love to make their data accessible, but it's a challenge to make it visible to the entire world in a way that's safe, well managed, and long lasting. So for data sets in kind of the sub 5 terabyte range, you just ask. And we're working on making that process be relatively lightweight, with a kind of 1 or 2 page description of the data set and its purpose. Over time, we're in the midst of integrating with Exceed, so that would become a kind of an Exceed mediated process using kind of the lightweight end of the Exceed allocation process. For larger data sets, storage is cheap, but not free. So we would work with you to obtain funding for new capacity, and then work that in, and then integrate that in a relatively straightforward way with the OSN network and address space.
1 minute left.
1 minute, and that's all I have to say. There's kind of another tier of membership, which is to become actually an active member of the service. You can do that by hosting storage at your site. And if you host storage, you get a say in how it gets used. And you can do that either with storage that's already there, that you already manage, or some sites don't want to have to worry about the details, and we actually have a pre-configured appliance that we can add, that we can install at your site. And then kind of one level up from that, we're happy to have people participate in governance and operation of the OSN. So if you want to learn more, here's a link to the Open Storage Network website. That's the bottom link. The top link, we're running a little seminar series. The next one is happening in January, that works on both kind of surveying the landscape of data sharing worldwide. We just had one last week that had speakers from Denmark and Germany, and also the US. And also just a deeper look at what the Open Storage Network is and where it's going. I could go on, but I'll stop.
Thank you, John. Thank you for the great presentation. For the sake of time, for audiences, if you have any questions, click the link on the chat and then contact John Goodhue. There's a contact information.